In this video, we are going to see about basis and dimension of a vector space. First, let us define. So, a basis, a subset V of a vector space V over a field F is called a basis of V, if it satisfies these two conditions. First condition, the subset V should be linearly independent. The vectors there should be linearly independent and B spans V. That is, V should be equal to the linear span of V. If these two conditions are satisfied, then you will call B as a basis for V. And then comes dimension. The number of elements there in V, you call it as the dimension of V. The number of elements in a basis of a finite dimensional vector space V is called its dimension, and the symbol we use is dimension of V. If V becomes a basis of V, then the number of elements in V will be the dimension of V. So now we'll see a sum where we are going to check whether this set having three vectors 1, 1, 2, another vector 1, 2, 5 and 5, 3, 4 forms a basis. So first we check the condition, first condition, whether they are linearly independent. So first condition will be to check whether the vectors are linearly independent. So what we do is three vectors are given and it is possible to form a determinant. So whenever it is possible to form a determinant, let us go by that. Okay, so determinant 1, 1, 2, 1, 2, 5, second vector as the second row, third vector as the third row. Now we evaluate the determinant value. Based on the determinant value, we will give the conclusion. So it is 1 into 8 minus 15 minus 1 into 4 minus 25, 2 into 3 minus 10. So we are just evaluating the determinant. This gives minus 7 and the second one is plus 21 minus 14. So we get minus 21 plus 21, that gives me 0. So determinant, suppose I call this as determinant A, I am able to get determinant A equal to 0. So this will imply vectors 1, 1, 2, 1, 2, 3, third vector 5, 3, 4, linearly dependent. So try to recall the condition. Whenever determinant A equal to 0, we say that the vectors, the three vectors are linearly independent. So the very first condition itself fails. Therefore, it cannot form a basis. Therefore, the set 1, 1, 2, 1, 2, 5, 5, 3, 4 cannot form a basis of R.K. Had the determinant been not equal to 0 and three vectors are there, then it would have been a basis. So here they have become linearly dependent. So it cannot form a basis of R cube. Now again the same one, only the numbers are different here. So here again we are going to check whether the three vectors 1, 2, 3, the three vectors are linearly dependent or independent first by considering the determinant. So let me take determinant A, the first vector first column, second vector as second column, third vector as the third column. So expanding a determinant by the first row and expanding it. So it is 1 into 2 plus 13. Then its second one, it is plus 3 into minus 6 plus 6. And the last one, 2 into 13. Yes. So this one is simplified. 32, first one, second one 0, third one 64. So what we observe is it is not 0. That is determinant A not equal to 0. Therefore the three vectors are linearly independent. The vectors are linearly independent. Moreover, we know that dimension of R cube is 3. Dimension of R cube equal to 3. Therefore, the vectors is set with vectors. Two, minus 3, 1, 3, and then minus 2, minus 10, 2, forms a basis of the dimension, of course, is 3. This is how we check whether the given set forms a basis or not.